In this video, we are going to see about stack ADT. So what is the stack? It is a linear data structure and it follows a specific order of operation where elements are added and removed from the single end. And here we are following the principle LIF, that is last in first out. The last item entered is the first item to be removed. Uh, so this all everyone know this last in first out concept, and we can see that chaply. So this is LIFO, and for example, if you see this diagram, the coins, the stack of pennies or coins are arranged one by one. It is arranged, and if you are taking outside, when you are taking outside, it is not possible to take the last one. That is first one you kept. Only the possible is the last one you kept can be taken out. And if you see this box and books and these things, so what else you are keeping first can be taken out only at the last. So what you are keeping last can be taken as first. So that is last in, last the kept boxes or last books can be taken out first. Last in, first out. So that is the principle of this last in, first out. So that is a principle followed in the stack, and we can see the stack model and the top. Okay, and this is a stack model, and here there are two operations we are going to use. One, it is called a push, and another one, it is called a pop. So already you people know what is push and what is pop. Push is for inserting any element in the stack, and pop is for removing the element from the stack or deleting the element from the stack. So we know the last one what we are pushed inside can be popped out first. Okay, that is the principle of the stack. So here we are having one thing that is called a top pointer. So top pointer is a one that is indicating, or the pointer, it is at the top where we are inserting. So here you can insert through the top as well as you can delete only through the top. The top pointer tracks the last element inserted. As the elements A, B, C are added, the pointer moves up. In an array, an empty stack is represented by top is equal to -1. The meaning is when the stack is empty, when nothing is there in stack, it is mentioned as -1. So the pointer will be at the lowest down because nothing is there in the stack. The value of the pointer top is equal to -1. So when you are adding one element there, the top increases, another element there, the top increases, another element there, the top increases, like that. Okay, through that top we are going to insert the data, as well as through that we are going to pop the data. And here we can see two core operations, as I told earlier. Push is there, pop is there. Push is for inserting the data through the top, and pop is for deleting the element from the top. And we can see the insertion algorithm in the push operation. Insertion algorithm, first of all we want to check overflow. So if you want to push anything, if you want to pour water inside a bottle, first of all we want to check whether the bottle is empty or full. Okay, so if this bottle is full of water, whether we can pour the water inside it, no, it will overflow. So that is this, we have to check for the overflow condition for pushing the element inside. Means if already the stack is full, we cannot push the element inside it. If not full, so that what we can do, we can insert the element or push the element there, inserting new element at the position pointed by the top. So this is the diagram. Here the stack is there, it is checking, but we are having, it is not full, we are having space, so that 40 it is inserted in there. Okay, and then we can see the pop operation. So for the push operation we have check overflow condition. Here the pop operation we have to check underflow condition, meaning we have to check whether it is empty. If nothing is there, we cannot delete anything. If there is nothing in the bottle, we cannot take water from that, right? Similarly, nothing is there, we cannot pop anything, and so we are calling that condition as underflow condition. If not empty, access the element at the top. decrement top by 1 to remove that. So here for popping, the top will be pointing at the top. So if you are removing one thing, automatically the top will get decremented, it is coming down. So when you are taking push, it will be coming from down to the top. The top pointer will get incremented. When you are coming to the pop, the top value get decremented. And here already what we have seen, the two conditions, stack overflow and stack underflow. Stack overflow is pushing an element when the stack is already full. Critical check for static array implementation. Stack underflow is popping an element when the stack is empty. Okay, so for popping an element, we have to check whether the element is there. If nothing is there, we cannot pop anything. So that we have to check whether the stack is empty. Okay, similarly, if you want to push anything, we want to check whether the stack is full. If it is full, we cannot do anything. Next, we can see implementation steps, methods. Two implementation methods are there. One is static implementation and another one is dynamic implementation. So the static implementation is it uses array to store the element, and dynamic implementation is uses a linked list to store the elements. So when you are taking the comparison between array and linked list, array is the size will be fixed, fixed at a compile time, and linked list means it will be dynamic. If more number of content are there, it automatically extends the space there. And array, it is simple logic but prone to overflow. And linked list, it is the flexible size, as I told earlier. Based on the input given, it will be extending the location. And this is the example declaration here, and no predefined limits are there. And then we can see array implementation. The second method, it is first method, it is array implementation basics. We can see about the array implementation. Next, we can see about the linked list implementation. Array implementation basics first. Uh, Here we need to check empty stack, as well as for pushing the data, we want to check the empty stack. For popping the data, we want to check pushing the data. We want okay, for both we want to check. For one thing, we want to check a underflow condition. Another one, we want to check overflow condition, and both we want to initialize top value. Okay, if it is -1, it indicates that stack is empty, right? So here we can see using the array implementation how the implementation is done. First of all, see here the top, it is initialized to -1 and array declaration has been given. And now we can see routines for full and empty in this array implementation, and this is very important. And is full of is there, the top is array size -1, so the meaning it is full. Array that is array is full, so that we cannot push any operators, push any content there. Similarly, if you are coming to the is empty, here top is equal to -1, indicating that stack is empty. And next we can see how to write the code for the push operation. And this is the method for push operation. Void push is it is given if the top is equal to array -1, that is stack is full, so that we cannot push. Another parallel case, if the false condition, if nothing is there, the top it is getting incremented, so that we can insert the data one by one in the array. And next one, pop operation. The same thing here. It is something different from that. If the top is equal to -1, we have to check for the empty, that is underflow condition. For the pop push operation, we have checked the overflow condition first, and the else part we have written the true case. Here we have to check the -1, that is underflow condition, and else part we have to write the true case, that is If nothing is there, we cannot remove. If something is there, we want to remove so that the top becomes top minus 1. And next we can see, so these are the linked list operations. First we have seen how to initialize top value, how to initialize declare the array values, and then we have seen how to write the push operation, and then we have seen how to write the pop operation. Next we can see how to write the implementation using linked list. So here two things we are taking, that is front. When it is called a front of the list acts as the top. Instead of top, here we are giving the word front, and we are going to have the push pop. SMT is for checking the condition, and then so these are the two operations as we have seen earlier, push and pop, and we know insertion and the deletion will be done at the same place, that is at the front. Allocating a new node in the front, check for underflow condition, storing the top node, update the head to the next node, everything it is done during the pop, and updating the head to the new node also done in the push off. And this is the comparison between the array and stack implementation using array and linked list. The size is fixed here, dynamic here, and waste space if empty, efficient allocation can be done in the linked list, and underflow condition has to be checked here, and here the access at tough speed it is faster, and here it is slower. So in this video we have learned about the stack implementation, stack ADT, and stack implementation using a linked list as well as using array we have seen, and operators, push operator, pop operator, how the routines are there, how it is working, the coding for all these things we have seen, and what is LIFO principle, and to condition, overflow condition and underflow condition, all these things we have seen here. Thank you.